Hello, hi student. Today we are going to see the concept of supernode. Okay, so this is what concept of supernode. Supernode. Concept of supernode in circuit theory. Okay, circuit theory. So concept of supernode in circuit theory. So let's see. By solving one questions, based on that we will understand the concept of supernode. So that is what, see, let us take one example. This is, let's say this is my current source of 2 ampere and this is my resistance of 2 ohm and this is my another resistance of 4 ohm and here this is voltage source. This is my voltage source of 2 volt and this is resistance of, let's say, 2 ohm. This is resistance of 2 ohm and here this is current source of 1 ampere. Okay, so 1 ampere. This is my voltage V1 and this is my voltage V2. We have to find this V1 and V2 and this is ground. Okay, so the problem is about what is the value of voltage V1 and V2. Okay, so now you see here there is a current of 2 ampere coming and here 1 ampere of current is coming. Now here if we see here how much current is flowing through this voltage source. If you will see, like, let's say current I is passing through this voltage source. Okay, voltage source, how much current? I. So if you see this I is equal to how much? I is equal to V1 minus 2 minus V2 divided by, what is the resistance here? Is nothing but resistance is what? 0. Yes, so resistance is 0. This much amount of current is passing through this voltage source, means something by 0 is nothing but infinite amount of current is passing through this voltage source, which is not possible at all. Yes, so which is not possible. So that's why we can say that, so amount of current that is passing, how much? Infinite amount of current, which is not possible. So therefore we can say that here these two terminal voltage and this loop, this two terminal voltage, we will consider it as a 1 volt. Okay, we will consider this as a one node, common terminal node. Okay, so we are assuming this, we are taking this as a common terminal node. Okay, so for time being, so therefore we will take this as a common node and after that we will apply the KCL. We will apply the KCL on this common node. So where there is no voltage at all in this terminal, so means V1 and V2 voltage both will act simultaneously. Okay, so simultaneously. So therefore we are going to apply what? KCL here. So let us make this somewhat smaller. So here first we are going to apply KCL here. Okay, so this is my V1 by 4, because V1 minus what is 0. So because this is reference voltage is how much? 0 volt. So V1 minus 0 divided by 4 plus how much current is coming here? So this is how much current is coming here? Minus 2 current. So minus 2 then here and directly go there. Okay, so simultaneously these two voltage are acting. These two voltage terminal voltage are acting simultaneously. So here next is plus how much current is there in this node? How much current is entering or leaving? If you see V2 divided by how much? 2, then how much current is coming? 1 ampere of current is coming minus 1 ampere of current is coming equal to 0. Okay, so this is what my one voltage equation. Okay, so that we have formed from the supernode. So let's see here, let us make this. Okay, so this is my small one equation. So if we solve this, what we will get here? So this is V1 by 4 minus V2. So this become what? V1 by 4 plus V2 by 2. This is 2. This is 1. 3 means minus 3, and this side it become plus 3. Okay, plus 3. So what is the equation that we will get here? This is V1 plus 2 V2 is equal to how much? 12. Okay, if we solve this equation, we will get this voltage equation. This is my equation number 1. This is what my equation number 1. What we have done, what we did here, we just apply the KCL. Okay, so we should take these two terminal as a common terminal node. Okay, so then after that we will apply the KCL simultaneously at this node and this node, and assume this node has out of the circuit for the time being. Okay, so then we get one voltage equation. This is what V1 plus 2V2 is equal to 12. Okay, so this is my one equation, and another equation, if you see, this is my one equation, and another equation is what? Another equation, we will apply the KVL. Okay, so because here we do not need to apply only KCL, so we need also apply KVL. KVL through what? Supernode. Okay, so we are going to apply now KVL through supernode. What is that supernode? If you see here, this is KVL through supernode. KVL in the supernode. What is the supernode? This is my V1. This is 2 volt. This is V2. Now we are going to apply KVL from this terminal to this terminal. So that is what? V1 minus 2 minus V2 is equal to what? 0. Okay, so this is what? V1 minus V2 is equal to 2. So this is my another equation. Yes. So therefore now we are left with two equations, two unknown, and hence it is possible to calculate the value of V1 and V2. How we will calculate here? If you see here, V1 is equal to 2 plus V2. V1 is equal to V2 plus 2, V2 plus 2, and by putting this V1 into this equation number 1, so what we will get here? By putting this V1 into equation number 2, this V1 plus 2V2 equal to 12, what we will get here? We will get, by putting this V1 into equation 2, what we will get here? V2 plus 2, V2 plus 2, then plus 2V2 is equal to how much? Is equal to 12. Is equal to 12. Now, what is the value of V2 here? So now we can rub this one. Okay, so this is how much? 3V2. Just wait. Okay, so this is what? 3V2 is equal to what? 40. Okay, so therefore what is the value of V2? The V2 that we got here, V2 is equal to how much? V2 is equal to 14 by 3 volt. Okay, so this is my V2 voltage. How much? 14 by 3 volt. V2 is equal to 14 by 3 volt. Then V1 is equal to how much? V1 is equal to, now you just note down it, and after that I'm going to put this V2 into V1 equation. From here we will get value of V1. Okay, so here now what is the value of V1 from this equation? See here, V1 is equal to V2 plus 2. What is V2? 14 by 3 plus 2. Okay, so which is equal to 6 plus 14, 20 by 3 volt. 20 by 3 volt. Okay, so therefore now we have what? We have calculated the value of V1 and V2. So value of V1 is what? 20 by 3 volt. Okay, so therefore we are now left with final value of V1 and V2. So that is what is the value of V1? Value of V1 is 20 by 3 volt. 20 by 3 volt. Okay, 20 by 3 volt, and value of V2 is 14 by 3 volt. So that what we have applied here, super node. Okay, so super node concept. So in summary, we can say that what we did first, we see that here the current is, here the infinite amount of current is not possible. So because no resistance is existing between these two nodes, so therefore we should take it as a super node. Okay, so then after that what we will do, so we will make these two terminal node as a one single terminal node. Okay, so single terminal node. So then after that we will apply what? KCL simultaneously at this node and this node. Okay, so then after that we got one equation in term of V1 and V2. So this is over one equation that we have seen. Then after that another equation that we can obtain from by applying the KVL through the super node. So that is what? V1 minus 2V minus V2 is equal to 0. Now we are left with what? Two equation and two unknown. So therefore we got the value of V1 is equal to 20 by 3 volt and V2 is equal to 14 by 3 volt. So this is what? Super node concept. Super node concept, you can just check it by passing the current through that branch where there is no resistance at all, and the current through that branch is what? Infinite. Okay, so which is not possible at all. So therefore we should take that voltage source as a super node. So then we should take the terminal voltage as a terminal node. So we should take the adjacent terminal node as a super node. So between which only voltage source exists without any resistance. Means in the absence of resistance, voltage source is existing between two terminal node. Then that node we can consider as a super node. So that's all about this supernode concept, and we have seen how to find the terminal voltage when there exists a supernode. Okay, so that's it. That's all for today. Thank you very much. Thank you.